Hey everyone! So, if you feel like you're hearing the words nuclear fusion pretty much everywhere these days, you are definitely not alone. It's all over the news, from huge lab breakthroughs to these massive promises about the future of energy. Today, we're going to dig in and figure out why fusion is having such a huge moment right now.
You've almost certainly heard the big, flashy promises, right? Things like limitless clean energy or a star in a bottle. But what does that actually mean? Is all this buzz just hype, or are we really standing on the edge of something that could change everything? Well, let's dive in and find out.
Okay, so the reason for all this buzz becomes crystal clear when you just look at this timeline. The pace of progress has just, well, exploded recently. In 2021, a reactor in China set a new record for endurance. And then came the big one. In 2022, a US lab achieved net energy gain. This was huge. For the first time in history, a fusion reaction actually produced more energy than it took to start it, about 1.5 times more. That single event lit a fire under the private sector, and 2023 saw this massive flood of investment, turning what was a science experiment into a full-blown commercial race. This rapid-fire chain of wins is exactly what's driving all the headlines.
So we know why fusion is trending, but what is it really? Let's get into the science of it. At its heart, the whole idea behind nuclear fusion is kind of breathtakingly simple, even though making it happen is unbelievably complex. What we're trying to do is recreate the power of the sun right here on Earth.
So, the textbook definition is that nuclear fusion is the process of smashing two light atomic nuclei together to form a single, heavier one. But here's where the magic happens. The new, heavier atom actually weighs just a tiny fraction less than the two atoms that made it. Now, that little bit of lost mass isn't actually gone. It's been converted into a truly massive amount of energy, thanks to Einstein's famous equation, E equals mc squared. And that right there is what scientists are talking about when they say they're trying to build a star in a bottle.
Let's break this down. First, you start with special types of hydrogen, usually deuterium and tritium. They're great because they're easier to fuse and we can find them in seawater. Then, you heat them up to absolutely insane temperatures. We're talking over 100 million degrees Celsius. This creates a super hot, electrically charged gas called plasma. Under all that intense heat and pressure, the atoms finally overcome their natural instinct to repel each other and they fuse. And the result? You get a harmless helium atom and a super high-energy neutron. Capturing the energy from that little neutron, well, that's the whole ballgame.
The science is just incredible, right? But what does it all mean for us, for our daily lives? And that brings us to the potential impact on public health. Because we really need to look at the enormous promise of this tech, but also weigh it against the very real challenges of making it safe.
You know, the biggest promise of fusion just jumps right out at you when you compare it to our current energy sources. Burning stuff like coal and natural gas pumps all sorts of harmful pollutants and greenhouse gases into our air. Fusion, on the other hand, it produces zero carbon dioxide. Its main byproduct is helium. I mean, literally the same safe gas you put in party balloons.
And the benefits here could be absolutely massive. We're talking about a future with dramatically cleaner air in our cities, a stable, super reliable power source that can keep our hospitals and critical infrastructure running no matter what. And here's a key difference from today's nuclear fission plants: the waste. Fusion doesn't create the same kind of long-lived, highly radioactive waste. All of this makes it an incredibly powerful tool for fighting the health crises caused by climate change.
But of course, no technology is perfect, and it's really important we look at this with a clear head. One of the main fuels, tritium, is radioactive, so it has to be handled very carefully. The materials inside the reactor itself will get activated by all those neutrons, and they'll have to be managed as low-level radioactive waste, though we're talking about it decaying in decades, not thousands of years. And like with any powerful technology, we have to make absolutely sure the facilities and materials are secure.
So, how do we tackle these challenges to unlock that amazing promise? Well, that brings us to our last section: data, safety, and our future. See, developing fusion responsibly isn't just a job for physicists in a lab. It takes a huge collaborative effort from experts in a whole bunch of different fields.
You've got entire teams working together to steer this thing in the right direction. Of course, you have the researchers pushing the science forward, but right there with them, you have public health professionals using these really sophisticated models to figure out the safety and population impact of every single design. And kind of holding it all together, you've got data scientists using AI to monitor everything, predict problems before they happen.
Which leaves us with the big question, right? Is fusion the key to a healthier future, or is it a complex new challenge? And you know what? The truth is, it's both. It holds this incredible, almost unbelievable promise of solving some of our planet's biggest problems. But actually getting there? Well, that depends entirely on us navigating all of the technical and safety hurdles with a ton of wisdom and care. So what do you think? What's the single biggest hurdle you see for fusion energy? Let us know what you're thinking down in the comments below. Thanks so much for watching.